Welcome back to The Explainer. Today, we are hosting a special exam prep masterclass tailored specifically for you infrastructure admins gearing up for the Nutanix NCP-MCI 7.5 certification. We are going to completely demystify Objective 16.4, which is the LCM update process. We're talking everything from the baseline requirements of AOS 7.5, AHV 11.0, and PC.7.5, all the way down to those super specific edge cases the test writers just love to throw at you. Okay, let's dive into this.
Here's our roadmap for today. 1. Why LCM matters. 2. The LCM update walkthrough. 3. Prism element versus Prism central. 4. Common exam tropes. And 5. Key facts to memorize.
Section 1. Why LCM matters. Establishing context and value.
Before we start memorizing the mechanical steps of an update, we really got to establish the underlying why. Understanding the foundational purpose of a tool gives so much context to its operations, making it way easier to recall specific behaviors when you're actually sitting there in the exam room. So LCM, it stands for Lifecycle Manager. It's an end-to-end update management tool that intelligently handles your firmware and software updates. Why is this absolutely critical? Well, aging hardware firmware without the latest updates is a huge security vulnerability. Traditionally, patching is a total nightmare, right? It's all manual compatibility checks across a dozen different components. LCM completely removes that headache. It calculates all those dependencies automatically, making sure you close security gaps without inadvertently breaking your cluster by installing a patch out of order.
Now, throughout this explainer, we'll be referring to Prism Element, or PE, and Prism Central, PC. Just as a quick refresher, PE manages a single local cluster, while PC manages multiple registered clusters from a central dashboard. And it is super important to note here that LCM is actually an independent module. It doesn't depend on the underlying AOS or Acropolis operating system or even the hypervisor version to function. You can comfortably access and operate the LCM framework right from both the Prism Element and Prism Central web consoles.
All right, Section 2, the LCM update walkthrough, step-by-step deep dive.
Now that we've got our context, we're shifting into the technical workflow. We're going to take a very deliberate pace here because understanding this chronological order is a massive part of the exam objective. So here's the core workflow of LCM. When you kick off an update, the very first thing LCM does actually isn't even on this list. It checks itself to see if the LCM framework needs an update. If it does, it auto-updates itself first. Kind of cool, right? Then it moves to step 1, performing an inventory of your current software and firmware across the cluster. Step 2, it runs a rigorous series of pre-checks to ensure the environment is healthy enough to sustain an update. Step 3, it generates an upgrade plan, intelligently grouping and batching available updates based on those strict dependencies we talked about. And finally, step 4, it executes the updates node by node, patiently waiting for data resiliency to return to normal before it even thinks about touching the next node.
And this brilliantly illustrates a critical exam point right at that pre-check phase. If a pre-check fails, the operation does not run, period. LCM will completely stop the update flow to prevent a catastrophic failure. It's not going to attempt to push through, and it won't just throw some soft warning in the background for you to ignore. It halts the process right there at that exact point in the logic tree so you can isolate and fix the issue before moving forward.
Building on the idea of the upgrade plan we just discussed, let's look a little closer at the planning phase. Here, LCM automatically calculates hardware dependencies and batches them to minimize cluster downtime. A perfect concrete example of this is on Nutanix NX platforms. LCM knows that a BIOS update fundamentally depends on the baseboard management controller, or the BMC. Because of that, LCM automatically batches these together so the BMC is always updated first, before the BIOS, on each and every node. You don't have to manually map that out on a whiteboard. LCM does the heavy lifting for you.
Let's hit a second concrete example, this time looking at those strict pre-checks we were just emphasizing. If you have non-migrable or pinned virtual machines, VMs, LCM cannot perform an update because it simply can't evacuate the node to put it into maintenance mode. So if your cluster runs AHV, the Acropolis hypervisor, LCM triggers a specific pre-check called test AHV entering pinned VMs. If you're on ESXi or Elastic SkyX integrated, it runs the corresponding ESEX test. If these pre-checks detect a pinned VM, the entire process completely stops, and the system literally lists the offending VMs right there in the UI so you can manually power them off or move them before trying again.
Moving on to Section 3, Prism Element versus Prism Central, operating scope and new export features.
So, Launching LCM from Prism Element versus Prism Central actually changes what you see and what you can do. And exam writers love to test your knowledge on exactly where those administrative boundaries begin and end. So the crucial point is understanding your visibility based on your login. When you log into the Prism Element web console and open LCM, you are strictly viewing the inventory for that specific local Prism Element cluster. However, if you log into Prism Central as an admin, head to the Admin Center, and launch LCM, your view expands significantly. You can see the inventory for the Prism Central cluster itself, plus the inventories for all the Prism Element clusters registered to that specific PC instance.
Now, speaking of Prism Central, we've got to talk about a highly testable new feature for the NCP-MCI 7.5 exam, exporting operations history. Starting specifically in baseline AOS 7.5 and PC.7.5, the operations history page lets you view and export all past LCM activities across your connected clusters. You absolutely must memorize this formatting detail. LCM currently supports exporting this operations history data strictly as a CSV, or comma-separated values file. If an exam question asks you about exporting to PDF or JSON for auditing purposes, you know right away that is definitively incorrect. It's always a CSV.
Section 4. Common Exam Traps. Navigating Edge Cases and Exceptions.
Pretty much every certification exam has edge cases designed to trip you up if you only know the basic workflow. Now, what's really interesting here is the precise mechanical behavior of the Stop Upgrade button during the download phase. Imagine an upgrade needs 3 image modules to complete. You hit Stop Upgrade while LCM is right in the middle of downloading the second module. What happens? Well, LCM doesn't stop instantly. It actually finishes downloading the active file of that second module, checks for the cancel intent, and then stops. It then discards all files from that incomplete second module. However, and this is the big gotcha test writers love, the first module, which completely finished downloading before you hit stop, that one remains safely saved in the LCM database.
Okay, here is a major prerequisite trap. While LCM automates almost everything, it cannot magically override external hypervisor management settings on its own. So if you get a scenario question involving an LCM update on an ESXi host, you must remember that you are required to manually disable admission control in vCenter first. If you miss this step, vCenter will block LCM from placing nodes into maintenance mode, and your operation is going to hit an immediate roadblock because the cluster just cannot safely shift workloads to perform the update.
And you've got to keep this hardware-specific exception on your radar as well. LCM Duo, which is the direct upload option, and dark site web server methods are absolutely fantastic for air-gapped environments without internet access. But they do not support Cisco UCS hardware. Cisco uses a proprietary firmware retrieval mechanism that forces their UCS systems to connect directly to Cisco servers to fetch updates. Because of that, Cisco firmware upgrades are strictly supported only for connected sites. That distinction between a connected site and a dark site, that is a prime candidate for a tricky multiple-choice question.
Almost at the finish line. Section 5, Key Facts to Memorize, the final review. We've covered a lot of ground today, from the underlying dependency logic all the way down to strict CSV exports. Take a mental snapshot of these points. If you remember literally nothing else before you walk into that testing center, remember these 4 facts. Number 1, LCM pre-checks do not issue a mere warning, they strictly stop the update on failure to aggressively protect the cluster. Number 2, LCM handles dependencies automatically, always batching base components like the BMC before dependent components like the BIOS. Number 3, exporting operations history is done exclusively to a CSV file and requires a baseline of AOS 7.5 and PC.7.5. And number 4, hitting Stop Upgrade during a download allows the currently active file to finish, discards the incomplete module, but keeps any fully downloaded modules saved.
So, as we wrap up this explainer, I want you to think a bit beyond the exam for a moment. How does mastering LCM's automatic dependencies fundamentally shift your day-to-day workflow from reactive firefighting to proactive management? When you let the framework calculate the complex upgrade paths, you get your time back to actually focus on architecting a better, more secure infrastructure. Thank you for joining me on this deep dive. Good luck on your NCP-MCI 7.5 certification, and keep learning.